Welcome to the Henstitute. We're going to talk a little bit about what we just saw with our video on kind of introducing the concept of impulse and momentum. And I've got the main equation here, right in the middle. What I would actually say is this is a revised version of Newton's second law. Revised Newton's second law. Because if you actually take into account historically, Newton didn't actually describe his second law with a force equaling mass times acceleration. We use F equals ma all the time, but he never actually used the word acceleration. He actually said that the net force is equal to the rate of change in motion of an object. And a lot of people just interpreted that as acceleration. But what he was really saying is that the sum of all the forces was equal to mass times the change in mass times velocity, so that's here, divided by time. And what we've done is kind of rearrange it. So originally he had force was equal to a change in mass times velocity over a change in time. And a lot of people just interpreted that change in mass times velocity as a change in velocity over time, which gave us acceleration, and we've got good old F equals ma. But we can split it out. This mass times velocity is a thing called momentum. And when we bring the time over the other side, we get a concept called impulse. And so the idea is when you have an impulse acting on an object, which is the product of the force and the time, you actually get a change in momentum of the object. So impulse doesn't equal momentum. So here's what's going to happen with our lab coming up. I call it the Whiplash Lab, or sometimes the horizontal bungee jump lab. But the idea is there's going to be some kind of force sensor over here, and it's going to be attached to this cart. So we're going to have a cart that's going to actually be moving, and we're going to know the mass of this cart. And it's on a low friction surface, so low friction, we don't have a lot of force that's going to affect it. And then it's connected with this elastic cord. So the idea is the elastic cord is going to apply a force back on this thing. So it's actually going to be the part that's going to eventually apply an impulse. We're going to be measuring the force, and we'll measure time as well. The other part that we have is at the other end, we have a little motion detector. And this motion detector is basically going to sense where this cart is in relationship to it, so it'll actually be able to figure out its velocity. And its velocity is actually going to be in both directions. So it's initially going to be moving to the right, and then afterwards it's going to be moving to the left. So the idea is this cart is going to take off, it's going to go flying out, it's going to reach some point where the elastic cord is stretched out, and then it's going to snap back. So that's why I call it the whiplash, because the idea is if you were in that cart, you're going to be moving in one direction and then snap back into the opposite direction. So that's where we get this happening. So the idea is we're going to see if we can support this revised version of Newton's second law in our lab. And the main idea is we know that the product of the force and the time, which is a thing called impulse, should equal the change in momentum of the object. So we're going to measure all those quantities and see how close they come to each other. But a couple of key things are going to pop up. For example, my initial velocity and final velocity. Velocity is a vector. So that means that the direction is actually going to be important. So initially, if I treat this as a positive direction, afterwards it's actually going to have a negative velocity for the cart. So that's going to be very important. If I think about that, the direction of the force is also going to be very important because we're going to be dealing with this cart moving, but the cart is moving to the right and the force is acting on it, and we're trying to actually measure that. Now, the interesting thing is technically that force would also be negative because if I look at this, if my final velocity is negative, my initial velocity is positive, I'm taking a negative minus a positive, that means this whole side would be negative, so I need this whole side to be negative. The only way that could happen, because time can't be negative, is the force would be negative. So technically this force would also be negative. We're going to measure with the force sensor, so we'll see it as a positive value, but we could actually change that into a negative value if we wanted to kind of show this. So that's what our intent is going to be, and we'll see how things kind of work out. I hope you enjoyed this edition of the Henstitute as we look at the revised version of Newton's second law, which is impulse equaling change in momentum.